Okay, Marvin, I'm going to just do a recording, then I can share with you after. So if I have an IP address like this is a revision session, and then I want to find out the network address. This is chapter 12 revision. Let me just put here chapter 12 revision. Practical revision. So I have an IP address like this, and then I want to find its network address. It's find broadcasts. I may put here find, then I put these ones at the bottom. Broadcast address. And network address and broadcast address. I think that's what you're looking for. Let me just make sure this is okay. First usable and last usable. So this is what you're going to do. First of all, you find out chapter 11. I just found, when I went the other side, I found out this is chapter 11 and 12. So I'm looking at, so this is what you're going to do today. So I have an IP address like this. I need to find its network address and broadcast address. So I look at the first octet. Which network does it belong to? Definitely this one belongs to class C. Okay, belongs to class C, definitely, because of that first octet, the range. Okay, so I'll work out this 192.168.1.10. Okay, so if I AND this, use the method we call ANDing, to be able to determine its network address. Okay. So when I AND here, I'll get let's move this so they're together. When you're ANDing, it's like you're multiplying. Okay, it's like you're basically multiplying. Okay, that's what ANDing means. So you're going to do like what you call logic gates, and you AND. So when you're ANDing, you're going to multiply basically. So you're going to convert this 192 to binary. Okay, if you remember our binary conversions, so I'm not going to get into the binary conversions because we're already okay with that. Dot one will convert to this, then 10 if you miss the binary conversion class, then you need special attention for that one. I'm going to do it in this particular class. Okay, so this is what this IP address converts to in binary. So we are going to AND it with the subnet mask so we can get the network address. So when you're ANDing, when you're converting this to binary, 255 will convert to all ones. Ones will be all 255s are ones. So it looks like that. Okay, so we have that. Now we are going to multiply the zeros here to be able to get our network address at the bottom here. So I'm just going to do that. So I have one. This one, when you multiply one multiply by that one, you get one. Then one and one, you get one. Zero multiply by one, you get zero. So this one will be, actually these ones all be zeros when I multiply there. Then dots. This one, the one will only be the first one here. The next one will be a zero because one and zero will create zero. Then this one will create one. One and one will create a one. Then 0 and 1 will create a 0. Then 1 and 1 will create a 1. And then these three will be zeros. And you put a dot. Okay, and so you have zeros there. And then a 1 and a 1 will create a 1. Okay. And then the zeros, 0 multiplied by 0, obviously you have zeros there. And then 1 multiplied by 0, you get a 0. And then here you have, actually here we have zeros throughout. Those ones are all zeros. So multiply this by 0, you get zeros throughout. So this is the network address in binary. Now we are going to what we call reverse engineer it. We are going to, oh, sorry. Oh, this is the problem with using Word. I need a board. So I'm going to convert this back to binary. So I wanted to reverse engineer, so I should make this arrow face this side. Let me see if I can get an arrow here in my design. This is why the online class is a challenge because I have to figure out how to do this every time. So what I'm doing, I'm just going to convert my binary here back to the decimal so that I can have my network address. Okay. So I'm just trying to get the arrow. Let's first color that so that it can be different. Need an arrow. take this back. Yes, maybe this one will work very well. Let's make it a little bit smaller. Okay. Right. Okay, so I need this. So this 1100 converts to 192 in binary. So this one will be 192 dots. This one here will convert to 168. If you remember your binary conversions, if you don't remember, we have to rehearse that class. You have to request for that class. And then 1, this one will convert to 1. And then this one, all zeros, obviously converts to 0. So when you have all zeros, that's what it will convert to. So this is our network address in binary corresponding to the 255s there. But this time I made sure that you see how we work it out. Usually we just say, where you see 255s, that octet stays, okay? But now here it shows you exactly how it stays in place. It's back there so it can be uniform. Marvin, what are you trying to say? Marvin, are you saying something? Marvin, you're saying something? Okay, so
no.
yes, I tried to. Yes, I can hear you.
No, I didn't say anything.
Yes, I can hear you.
Okay.
Yes, you're saying. So yeah. I was just converting. I was just trying.
What are we doing right now?
As you can see up there, I put a title, chapter 11 and 12, the practical revision for those 2 chapters I promised. But the good thing, I've recorded this as well. So I'll be posting it on those chapters. Maybe let me just indicate this one as chapter 11 so that I can post it in only chapter 11. Then 12, I will do it, post it in chapter 12 because I'm starting with 11. Okay, so I'm converting. Actually not converting. I'm getting the network given an IP address like 192.168.1.10. We are trying to find its network address and broadcast address. Okay, so if you're given an IP address, you're able to find its network address and its broadcast address using what we call ANDing. Okay, so this process is called ANDing.
Using adding?
And let me write it here.
ANDing.
It's called ANDing. Yeah, like AND. Okay, it's called ANDing. So this process is called ANDing. Okay. ANDing is like multiplying. We compare a 1, if you what you call logic gates, you call them logic gates. It's in digital logic that if you have a 1 and a 1, that creates a 1. Like a true and a true, you have a true. If you have a true and a false, then it is false. So 1 is a true, 0 is a false. Okay, that is the concept of ANDing. Okay, so that means if I have a 1 and a 1, if I'm comparing a 1 and a 1, I'll get a 1. That means if I switch on I want my light on and I switch it on, I have a bulb and a light switch, I switch on, the bulb will come on. Okay, however, if I have a switch and I don't have a bulb, so you see I have a true, I have a switch, but I have a false, I don't have a bulb, then my light will not come on. Okay. If I also have a bulb, but I don't have a switch to switch it on, then that's a false. It will be a 0. I will not have any light because I don't have the switch. Okay. So, but if I have a light, a bulb, I have a bulb and I have a switch, a light switch, then I'll get light. You see that? So a true and a true make a true. Okay. So a true is a 1, a false is a 0. If I have a false and a false, then I remain with a false. Okay. Yeah. So that is how ANDing works, and that is how a computer works. Okay. It compares two variables. If they are both true, it will give you a true result. If one is false, it will give you a false. If they are both false, it gives you a false. Okay, that's how ANDing works. And it's like multiplying. If you ever forget what it is, think about multiplying. It's like multiplication. Okay, a binary 1 and a 0 make a 0. A 1 and a 1 make a 1, and then a 0 and a 0 make a 0. And that's what you're doing. So what you do, you get the IP address which you've been given, which was this one here. Okay, I've been given this IP address. I don't even have a slash. Okay, I've been given it like that, and then they've told me find the network address of this IP address and also find the broadcast address of this IP address. So what am I going to do? I'm going to first find the network address. When I find the network address, it will be easy for me to find the broadcast address. Okay, how? You first convert the IP address here to binary. Okay, and then you compare it with its subnet mask. How did I get the subnet mask? You remember your classes. Okay, you get back to remembering your classes. You always use the first octet. Okay, do you remember that? You always use the first octet when you're working with IP addresses. To get its class, look at the first octet. And this our first octet is 191. And if you remember our classes, we said that between 0, 127, between 0 to 127, it's a class A. You remember that? This was a class A. Okay? This is class A. Then between class B will be from 0, sorry, I hear 0. From, I'm sorry, I'm starting to get tired. I've had a long day. Then from 128, you just continue from the 127, okay? From 128 to 191, this is a class B. Okay, this is a class B. So this one is a class B. Okay. Then if you have from 192 to 223, this is a class C. Okay, this is a class C. Okay, then if the first octet is from 224 to 239, this is a class D. Okay, you have a class D there. That's a class D. Okay, and then class E is the last one. Class E will come last with 240. You just continue from the 239 there. You go to 240, 240 to 255. The last, remember our last octet is, each octet ranges from 0 to 255. So the last octet will be 255, and this is a class A. So we said class A, the first octet should be in this range. So this is definitely not a class A. class B should be from 128 to 191, and this is definitely not a class B. So definitely it will be a class C because it's ranging from 192 to 223. Okay, so it's a class D. So this is our class that we are looking at. Okay. And remember class C, the slash format. Remember the slash format? For the slash formats, these are the classes. And remember, we also have slash formats for each and subnet masks. Okay. So the subnet mask for class A is 255, the 1255, okay, just the single, 0.0. Then this one we are going to increase 255.255. We increase by 1.0.0. Okay. So for class B, class C, sorry, we increase again on the 255s. Okay, that's a subnet mask for class C. So this is the default. These are the default subnet masks for each class. Okay. So if you're working with this IP address, it means that it's a class C, and this is this default subnet mask. And remember, I told you that each of them have a slash format. So this one will be /8 because of the 8 ones in the octet there. And then this one will be a /16 because of the 16 ones. Okay. And then this one will be a /24 because of the 24 ones there. Okay. Because here you're looking at 8 ones. Dots, then the zeros will all be there. Okay, so it looks like that. So this is the default subnet mask for class A. Okay, then for class B, you continue doing the same. For class B, you add on the 255. Remember we said that this one doesn't have. Class D and E don't have subnet masks because we don't use them. We only use class A, B, and C. So D and E don't have subnet masks. So let's do it. So this one will have 16 ones. Okay. That one will have the 16 ones like that. And as you increase, the ones also will increase. Okay. Then class C will have just one octet of those zeros, and then the rest will be ones. The rest will definitely be ones, all of them. So we have that. Dots. Okay. So this will be the that will be the octet for class C. Okay, it will look like that. So as you can see, we you have that continuity for each of them. When you convert 255, you have 8 ones, as you can see. So it looks like that. Okay, you keep increasing on the 255. So that means that our default subnet mask here is a /24. Okay, so you do that, you slash 24 there, what I did earlier on. Okay, that's how I got the slash 24. So when I come down, so when I came here, so Marvin, up to this point, you get me?
Yeah.
Marvin, you're getting me there? Yes. So,
Yeah.
so here, I now took down the IP address, being that now I know it's subnet mask. So I wrote it below that. Okay. And then I'm going to add it so that I can get the network address. The IP address uniquely identifies the PC, and then the subnet mask will uniquely identify, will help us to identify its network address. Okay. And that's why I always say the subnet masks helps the PC to know to which network it belongs to. This is how it does it. It compares the IP address and the subnet mask, and then it gets the network address. Okay, like that. So that's how I got this. So I converted the IP address here to binary, and then I also converted the subnet mask also to binary. And then I added, and then I got this. This is now the network address. Okay, so the network address looks like that. So I would say here, therefore, the network address, it says so. Network address will be equal to that. Okay. So that's how I get the network address. I don't know whether it's clear there. Alvin, are we together there?
Yeah.
You think you can get the network address if you've been given an IP address?
Yeah.
Yeah, so they're going to play this trick on you, okay? They'll give you an IP address, and then they will ask you to get the network address or broadcast address for that IP address. So just remember to use the ANDing in this way. If it's a class B, you would have the IP at 172 here, .10.5.5, and then you AND here with only 255.255. Okay, then you'll be able to get the network address at the bottom there. Okay, now we are going to get the broadcast. Okay, the broadcast address for this network. What's the broadcast address? For the broadcast address, it's very easy. After getting the network address, you now get the last address on that network. It will automatically become the broadcast address. The first IP address on this network is this one. It's a network, it's a .0. Okay, the first IP address is this one. The last IP address will be .255. So the last IP address on this network, since the first one is 192.168.1.0, that means this 0, I'll count it up to the last octet, which is usually 255. Okay, so the network address is usually the first IP address of the network, and then the last address is always the broadcast address. And these two addresses, we say that we don't use them. They're not supposed to be used, they are reserved. Okay, the network address uniquely identifies the network. The broadcast address helps to send broadcasts. Right.
So why do we need to calculate it?
Yes, the broadcast. You don't need to calculate it. You don't need to calculate the broadcast address. You just get the last IP address on that network. The first one is a .0. Remember, these first ones don't change. Okay, you remember? These first ones don't change actually. Yeah. The first one here doesn't. The first octet doesn't change because of the subnet mask. Okay, where you see the 1s, the 255, that first part of the octet is not supposed to change. You only change the last one. Okay, That means the first IP address on this network is .0, last one is 255, because 255 is the last octet on the network. Okay. And then in between there, you can now have .1, .2. So you know the usables. Those are we call them usable IP addresses. Usable host addresses, IP addresses. So the usables, sorry, the usable IP address are usually from there. So you say 192 dots. Actually, let me just copy and paste this one so I don't have to keep typing. So the usables, dots, there should be a dot here. So you start from .1, okay? .2, .3. The usables are the ones now you give to the PCs on that network. Okay, maybe you're designing the other network, so you're starting to just design it slowly. You're going to design it very slowly. Your PCs, you're now going to start giving them IP addresses in between 0 and 255. Okay, any number in between there is okay to give to a PC. But the first IP address, you always give it to the router. Okay, so .1 goes to the router. Okay, .2, then you come here, you put also the .2. You put the .2. Okay, .2 will come here. .3. I hope you're getting me, Marvin. The rest of the class, when they hear the recording. .3, you go like that. .4, .5, all the way up to 255. Okay, that's how you move all the way to 255. But these ones are the usable ones. Okay, these ones are the usable ones. The network and broadcast, we don't use them. Okay, you're going to use the ones in yellow. Okay, so you keep going. If you have 100 PCs, you count 1, 2, 3 up to 100. Okay, so you keep giving. If you have a DHCP server, it helps you to automatically give the IP addresses. So you just set the DHCP server with those IP addresses, and the server will keep automatically giving them out. Don't give your computer .0. Don't give .255. Okay, I don't know if I make any sense there. Okay. Marvin, do I make any sense? Do I make any sense there? So this one will be .4. Okay. Then .5. .6. You see that, Marvin? So usables mean that you are going to give them to the PCs. Okay. You're going to give them to the PCs, the switches, the routers. Okay. But this one here becomes the default gateway. It's good to give this one to the default gateway. Okay. Give it to the default gateway. So it will go like to the router. Okay. Like the router or the server. The one connecting to the internet. Okay. The server that connects you to the internet, you usually call it a proxy server. Okay. So you can give it to your default gateway. Okay. And then .2, .3, .4, those ones all go to your PCs. As many PCs, this network will give you up to 253 IP addresses. Because remember, 0 and 1 we don't use. So it's 255 minus 2. Okay, we don't use .0, we don't use .255. So you have up to 253 IP addresses that you can work with. That's the minimum for this network. Marvin, are we there? Can I give you another example? Okay, I hear you moving your lips, so that means a yes. Okay, so let's take another example. let's take a class B now. Okay, so that's 172.16.0.50. Okay, so we have this IP address. We are supposed to find its broadcast address. Okay, find the network address, then I'm also going to find its broadcast and address and the usables. So we shall put the usables in between later on. Okay, after we find the network and the broadcast, then we fix in the usables. Okay, later on. So I'll just start with these two. So to find the network address, the first thing you're going to do for this one, you will first of all find out which class does it belong to. Okay, which class does it belong to? So we go and look at the first octet, okay, which is 172. Where does it belong? Okay, which class of IP address does it belong to? So you go up. Remember our classes, class A, B, C, and D. So 172 falls between 128 and 191. So it's a class B. Okay. So we go down and work with that. Okay. Just put it here. So it's R. It's a class B. Okay. So we are going to make this one right there. This is our class. So this one belongs to class B. And this is its subnet mask. So class B by default, this is its subnet mask, that is its slash format. The slash format meaning the number of ones you have in that first network portion, okay, which is 16. But the subnet mask looks like that. Okay, so we are now going to okay, so that we can get the subnet mask. So we know that it's going, this IP address will be a slash 16. Okay, it's going to be a slash 16. Okay, so it's a slash 16 according to this, our defaults. Okay, and that's the subnet mask. This is its subnet mask. So we are going to come down and work with that. So I copy here, just come down. So I start working out the network address. Okay.
Where you put the 54?
I just made up the IP address.
I'm talking about like when you're writing the subnet mask, right? 255.255.0.54. Then you write.
No. In the subnet mask,
you have 16 ones.
In the subnet mask will be 255.255.0.0, not .54. 54 is the IP address. Yeah. So our IP address will be like that. Now we need to have the subnet mask at the bottom. So we compare it with the default subnet mask. Sorry. This is our subnet mask. Okay. So you see, I put the IP address up here, and then I put the subnet mask at the bottom that we are going to compare with. I'll just move this so that they can be on the same level. Yeah, we're okay now. Okay. So here we are going to now AND. We are going to AND. Okay. I'm going to be about ANDing. Let's get space here so that I can write my word ANDing. So we are going to AND, and remember, ANDing means that you are going to put ANDing here means that I'm going to put I'm going to multiply. Okay, ANDing means that you're going to multiply. Okay. Okay, so you're going to be multiplying that. But we cannot multiply the way it is. We have to convert to binary. However, if you're working with the default subnet mask, you can just do it automatically. Okay. You can just do it where there are 255s, you know that will be, it will just stay the way it is. Each that octet stays the way it is. So you have, so at the bottom here you have, oh, I'm already at the end of the page. Okay. Take this to the next page. So here I have 172.16. Those two octets are remaining because of this 255. Okay, the 255 is corresponding with these two octets. So those two are not going to change. But what is going to change is these two octets. These two are going to change because I have two zeros there in the subnet mask. So those two are definitely going to change. So I'm now going to reset my network address here to 0. Instead of having 54, that one will also be a 0. That one there. Okay. Why? Because now these ones I can play with them anyhow. I can put here .1, .60, .1, .100, .50, .3, like that. You can play with these two octets, but these ones I should not touch them because of the subnet mask up here. That's what it means.
So you can do ANDing without writing it out and putting the
yes, you can do it without
11100.
Yes, you can do it without. However, we do. I taught you how to do the 1-1 because sometimes the subnet mask is not always the default. Okay, it can be a different subnet mask. It can be like, for example, it has been subnetted. It's a slash something else. Okay, it like this one can be, instead of being a /16, it can be a /20. Okay, so we are going to work with something like that. It comes to that. Okay, so but the broadcast address here now is going to be what?
172.16.
Okay, I'll write as you talk. Yeah. 172.16 dot
That 0.
No, because
That
of
255. The 255.
Yes, 255 because of these two zeros. Okay, so you already start
The
here with
255.
255.255. So that will be the broadcast address for this network. Okay, so this is the network, this is the broadcast. Now I can play around with these two octets. That means that this network is going to give me more. It's going to give me more users than the previous one, than the class C. Class C will give me a few addresses, you see there, because I'm only working with the last octet. Okay, I'm only working with that last octet. So it will give me very few addresses. I can't change these three. But now with this one, I can have more addresses because now I'm changing 2 octets. So I get to use more addresses. So that's why class B is a medium size network. Okay. All right, let's work with the class A. Okay. So I have 10 dot 100 dot 5 dot 9. Okay. So I have this IP address. Okay, so Marvin, I have this IP address. I'm supposed to find its network. I'm supposed to find its broadcast address and the network address. What's going to happen? Load your.
All right, so
Class
you're
A.
gonna figure out that that's in class A.
Yes, it's a class A. So that means that now I have the subnet mask as what? Now this one you can even do it directly. My subnet mask is now going to be 255 dot what, Marvin? The subnet mask?
0.
Yeah, dot 0 dot 0 dot 0 dot 0. Okay, I'll just move this one so that they can correspond with the other one, like that. So it's going to be 255 dot 0 dot 0 dot 0. Okay, sorry. Okay, like that. And now we are going to AND. Okay, now when you AND this, you're going to have
10.
Yeah, to be 10. This one won't change. Dot 0 dot 0 dot 0. So all these ones are going to remain 0 because of the 3 zeros there.
That one, how come that one you can't do 255, 255, like in class B? Like the broadcast address and that.
Oh, sorry. So that means you're awake, Marvin. You're awake. I thought you're sleeping, but you're awake. Thank you for being awake. Yeah, you're very right. You're awake and alert. While me, on the other hand, I've started sleeping. 255. So the broadcast address always resets to 255.
255.
Yeah. So I'll move this so that they can correspond to the broadcasts. So I'll correspond there. Okay, so they correspond easily. So those zeros reset. So this will be the broadcast, this network. Now there's a challenge. Okay. If I have subnetted this network, I have like a /27. Okay, like I have a class C 192.
One question real quick.
Yes, I'm
What's
creating the question.
Okay.
This is my IP address, and my slash format is not 24 anymore. It's now 27. And I'm supposed to find the network and broadcast address for this network. What happens?
So you have to write it down, write out the subnet mask.
Yes, it's true. So you have to write it down, okay? So we have to go now back to the basics. We have to write down the 1, okay? So you get, we are going to convert the 192 to binary. Okay, so this one will be 11000. So you convert this to binary. Okay. I kind of know this IP by heart because I work with it all the time.
So, like on the test, we may want us to convert that to binary.
Yes. So it should come off your head. dot 6 is 0, 0, 0, 0, 0, and those are 5. So 6 converts to what in binary?
Three
These ones
zeros
are
and
all
one.
there. Yeah.
Six converts
It's
to is it 6 zeros
101.
and 3 ones?
Yeah, it's one. I think it's 101 because 7 is triple one. 7 is triple one, so this one should be 101. I subtracted the 1 from 777. I know 777 is 111. Sorry, 7 is 111. So use your, I don't know whether you guys know how to use your scientific calculator to convert. So you should not do this off your head, but I also need to show you how to use the calculator, because I showed you how to use the head last time. So if you're in your calc, once you've opened your calc like that, it opens in standard. So you need to change it to, you need to change the standard to programmer. So you click here, and then you change to programmer. Okay, when you change to programmer, you have your 6. Decimal is already chosen, so you have 6, and I want to convert to binary. Okay, so I get 0, 0, 1, 0, 0, 1, 1, 0 in binary. Okay, Marvin, you see how to do that? It's 110.
Wait, hold on. I was just opening up my calculator.
Hmm.
Okay.
You're there? So change the calculator from, usually it starts with standard, change it to programmer.
Okay.
You're there?
Yeah.
Okay. So you're going to write this down in our octets there. In our octet to be, because there are only 3 octets, but remember 3 bits, but remember there's supposed to be 8. So you put leading zeros on this side. You put 5 leading zeros to make 8. Okay. So I'm going to, oh, sorry, I speed stop share. New share. We're going back to our slide. Okay. So on my share, like I said, I'm so tired. I've been starting to make mistakes. 111 minus 1 is 110. I wrote 101. I took myself back. 111 minus 1 will give us 110. Okay, when you're subtracting in binary. Okay, so we come down. We come down and write out the 25 the slash 27. You just count them out. Okay, the slash 27, just count them out. So you need 8 ones there. Dot another 8 ones to make 16. Dot another 8 ones to make 24. And then 24 plus 3 will give us 27. That's my slash format. And then the remaining bits will be zeros. So I write there the zeros like that. Okay, so I have those zeros. So this is slash 27. You count out 27 ones. Okay, and then we are going to just underline it there so that we can get the network address. Okay. So we are going to add at the bottom here. So a 1 and a 1, remember you're multiplying, so it'll be as a 1. Sorry. This one will be another 1. And then this one is going to be, just a moment, I need to just move this a bit here so that it doesn't keep giving me. Okay, this is 0. A 1 and a 0 will give us 0. Actually, now the rest are going to be zeros because of this upper one. Okay, multiply that, it's going to be 0. So you have 6 zeros there. Dots. This 1 and the 1 will give us a 1. 1 and 0 will give us 0. 1 and the 1 will give us a 1. 0 and the 1 will give us a 1. 1 and the 1, sorry, give us a 0. A 1 and the 1 will give us 1. 0, 1 will give us 0. 0, 1 will give us another 0. So actually these ones are all zeros. Okay. Then when you multiply 0 and 1, you get a 0. So these ones are all going to be 0 except the last octet, the last bit, which is a 1 in the octet. And then it's 0, 0, 0, 0, 0, 0. Actually, all these are zeros. Okay, because when you multiply them, you get that. So this is our network address in binary. Now we need to convert it to decimal. We need to reverse engineer it to decimal. Okay, so I'm going to borrow my arrow here, which I had earlier on, and bring, oh, sorry. Arrow, you need to stay there. I just need to copy you down side. Okay. So there we go. So this is now going to give us one, the first octet here will give us 192 dots. The second octet will give us 168. The third octet here will give us 1. And then the change is going to occur on this last octet. Okay. Actually, this first 3, the octet should not change because it is all 255s. Okay, so it will not change. That's why. Okay. I also need to reverse engineer this one. When I talked of the octets, then I remembered I need to also reverse engineer this one to reverse it. I hope I'm using the term reverse engineer in the correct format. Because I was teaching some software class, we were doing reverse engineering, so the term is stuck in my mind. Okay, so this one also has to convert to a subnet mask on this side. Okay, so we have 255.255.255.0. Okay, so I'm just bring this back. Sorry, it's not dot 0. It's not dot 0. It is dot something else. It's not dot 0. It's dot. We need to convert this last octet to decimal. So we are going to add. This is 128. Let's remove the underline there. So be 128 plus 64 plus 128 plus 64 plus 32. The place values, okay? Remember the place values for this. This is 128, 30, 64, 32, and then you have 16, 8, 4, 2, and 1, but these ones are all zeros, so we're not going to add them. So we're just adding those 3, okay, which will give us 128 plus 64, that's 192. plus 32, 192 plus 32 will give us 224. Okay, so we have 224 here. That means that this octet here will be 224. Okay, so so you can see it was going to be impossible to add with this with the 224. That's why we had to convert that binary. Okay, so this is going to be dot 0. Okay, that last octet is going to be dot 0. Okay, but sometimes it changes. You may get dot 16, dot 34, sorry, 32, dot 64, dot 128. So you may get figures like that for the network address. This is because you have subnetted. When you default subnet mask, you usually use 0, 255. But when you subnet, we are going to handle subnetting next the next class. The next revision will be on subnetting. When you're working with subnetting, you find that you have such weird broadcasts and network addresses. You can have a network address as .32, .64, .16, okay? And then you have a broadcast address like .59, things like that, numbers like that. So this one, we are lucky that it's .0, but it could have been the network address could have been .16, .32, .64. Okay, so you don't mistake it with a regular IP address. So don't give that IP address to your computer because it will be a network address. When you subnet, the rules change. Okay, that's why it is called a custom subnet mask. Okay, VLSM or subnetting, the rules change. It will not be obvious that 255 will be a broadcast. You can find that 255 may be an IP address. Okay, yeah. So that's how it works. So we shall handle that when you're looking at subnetting. As long as you first understand this part, then subnetting will become easier and easier for you. Okay. Any question on this?
What's the broadcast?
The broadcast, the broadcast for this one. Oh, by the way, we didn't work that out. So we need to work out, the broadcast. The broadcast will be now the opposite of this, of the network. Okay, the broadcast will be the opposite of the network. So what you do with this one, what is the opposite of this network? You change the ones, you change these ones to zeros, and then the zeros become ones. That will be the broadcast. Okay. In mathematics, we say it's the inverse of this. Okay. The inverse or the opposite of the network. Okay. So we are going to convert. We are going to change this. So what I'm going to do, I'm going to just go down here and I do that. This will be the broadcast. I know we are going to definitely reverse engineer this one. Excuse me to use the word, but it seems nice to say it. Don't blooper me. Don't blooper me. Yeah, be like, I'll get a blooper saying the lecturer kept saying reverse engineering, you know. How these things nowadays go viral because there's lots of classes going online. So there'll be lots of bloopers too. But I'm not afraid of the blooper. Yeah.
When you go viral.
Yeah, it can go viral, you know.
Movie.
This IE lecturer kept saying that blooper. Okay, you know how Ugandans be. Okay, now I'm going to change. Oh, sorry. Yes, I'm going to convert. Just a moment. I'm going to convert these last bits here and change them the other way around. Okay, so I'm going to have these ones become zeros, and then these ones will become ones, like that. So you see what I just did the opposite of this. I'm looking at the last octet here. I'm looking at that last octet. It's too dark. Get something lighter. So I'm working with this and that. Okay. All right. So what does this convert to when you convert it to binary, to decimal, from binary to decimal? So just add this. We are going to add 16. So this one's going to be 16 plus 8 plus 4 plus 2 plus 1. What do you get? I'm just adding the place values of where these ones are. Okay. Remember, this is place value 128. This is 64. 32.
31.
Then this is, it's now 31, eh? Okay.
Yeah.
Thank you for being very fast there. So that's going to be our IP. That will be our octet. So everything here will be the same except that last octet. So I'm just going to duplicate this. Let's copy this here. Okay, so this one will be 31. And Marvin, that's our broadcast. That's how you get your broadcast. Okay, that will be our broadcast address. Take the last octet on the subnet mask and you inverse it. Okay, the zeros become ones and the ones become zeros. Okay, and then this side you leave that section the way it's supposed to be. You leave it like that because remember it's a network portion. You're supposed to tamper with it. So that one, you leave it the way it is, only change that last one, and that will be the broadcast. So in between here, we shall have the usables. We shall have the usables. So don't use on this network. It's now called a subnet. We're already subnetting, but I'll show you a better method for subnetting. We're already subnetting. So here we have .1. We shall have everything. Here, the first 3 octets remain the same except the last one. So this one will be .1. Okay. .2, .3, all the way up to 31. However, the usables are these ones here. These ones will be the usables. Don't give them, don't use, this one will be the network, and then this one is the broadcast. Don't use those two. We say they are reserved. The first one, this one, uniquely identify the network, and then this one, this last one uniquely, sorry, it's not uniquely identifying anything, but it's supposed to be used for sending broadcasts. If I have a broadcast message going out to the PCs on this network, I'll use this one. So if you look at it, it looks like a normal IP address, but it's a broadcast address for this subnet. All why? Because of the /27 that we had here. That's why. Okay, makes it a broadcast. Okay, so all the way, so on this network, give your PCs .1, .2, .3, .4. But remember, this first one will become the default gateway. Okay, this first one, always make it the default gateway. Give it to the router. Okay, give that one to the router, then the rest you can give them to the PC1, PC2, PC3, like that, and so forth. And then the subnet mask for these PCs will always be this one, not .2, not .0, but it will be this one here. Okay. The subnet mask for these pieces will be 255.255.254, not .0. Okay, because now you have subnetted it. Not to worry, I'm going to look at subnetting next. Okay, in the next revision, we shall do subnetting. Okay, so you can get it better. But so far, at least you can now get the network address, the broadcast address, and the usable IP addresses. Not so, Marvin?
Yeah.
All right, so any other question? Because I want to end the class. It's already 8:30. It's coming to 9. So that I don't take you too long.
We had a couple calculations we had to do from the other quiz.
Yes, some of them are here. However, the others we are going to cover them in the next week because that is subnetting.
Okay.
That one's now from here. We are now going to subnet. You can see I had already started mentioning it. Okay, once you understand this part, then subnetting becomes a better, much better area to understand. Okay. All right. So I'm going to send this recording. I've saved it, so I'll share it. So in case you want to revise, you can still come back here and do some more revision.
How do I find this? This is under the coursework on the
Yes, it's
Malabo
CCNA.
website.
Yeah, this is CCNA. Chapter. This is chapter 11.
No, but this is under Cisco or this is under the school. Where do I find the video?
The video you're going to find it in Melimo.
Okay.
Find the
And
video
then
in
look, like I
go
told you, right?
to the chapter for the video for each chapter. You go to that chapter. That's why whenever I was going to a video, I would tell you that let's first load into that class so that I record it in that class. That's the purpose.
Okay.
If you want a video for a particular class, go to that particular chapter.
It goes all the way to chapter 1.
Yes, but remember chapter 1 we did them at school face to face, so I don't have those recordings. So you have to start from where we started. But I'll be populating them as I get the recordings. I'll be adding them.
Okay. Look, so I told you my thing, my pocket tracer refused.
Yeah, he told me. Yeah.
Can I share my screen and show you?
Okay, just a moment. Let me stop this recording.